system.out.println, parenthesis, quote, hello, close quote, parenthesis, semicolon. Now, far more important than can you answer the question is, do you know what it means? So what is this system.out. business? Yeah, well, actually you don't know because I've never told you yet. Everything in Java is organized in some way. Now, println actually is the name of the function, the operation, the procedure, the thing that we're telling it to do. So println is what we want to accomplish, and println is located inside of an object, or inside of a class, excuse me, called out, which is located inside of a namespace called system. Now, to make a long story short, it's an organizational thing in Java. You just have to type the whole thing to print something. Now, if you're interested, you can actually, at the top of your Java program, you can say import system.out if you want. And then you can later just say out.println. And the idea of import here is it says, hey, whenever I say out, I actually mean system.out. It's kind of a shorthand notation. Now, that's not really critical or important. It's just something you can do. So when you see code that does that type of a thing, you'll know what's going on.
So print is more or less a built-in function of Java.
Yeah.
So you don't have to.
That's exactly correct. Print is a built-in function. It comes with you. It's part of the Java class library. Now, if you just said println, Java is going to panic and say, I don't know what you mean, because you didn't write a function called println that's actually located inside of some Java class called out. So you have to really say out.println to tell Java what you're talking about. And in fact, you really have to say system.out to give it the full explicit path to the name of the function. Unless you have an import command, which basically is a way of saying, I'm tired of being explicit. Hereafter, I don't want to give you the full path. Okay. Hey, look at me. I just turned a test question into a teaching opportunity. Okay. Now, why parentheses?
It's a string.
Quotation marks are why it's a string, actually. The parentheses are the way of signaling to Java, I'm doing a function call. So what's a function call? Think of a recipe. Suppose you want to bake a pie. Put some cherries in a pot, add some sugar, stir in some cornstarch, turn on the heat, stir it for 20 minutes, etc. And then the recipe is going to say, and put it in a pie shell. And where do you get a pie shell? Well, it's going to say, see page 21 for instructions on making your crust. So I turn to page 21, and there's another set of instructions for take your flour, stir it, mix it with some Crisco, whatever the instructions are for making a pie crust. And if I don't have any flour, it'll say turn to page 212, go grow some wheat, take it to the grinder, mill it. I mean, if we really had a complete cookbook, there would be instructions, but then there would be sub-instructions and sub-instructions, and we could get down to how to chip a millstone out of a mountain rock if we really, you know, if we were down to it. And then at that point, we'd probably need ore to molten the tools that we wanted. If we were rebuilding all of civilization from scratch, it'd take a lot of instructions to bake a pie, would it not? Okay, well, nobody wants to see all of the instructions for civilization from scratch every time you want to bake a pie. Certainly you don't want to regrow the wheat. So they just provide the instructions at a high level. It's add flour, stir it with the Crisco, pour in the topping, right? That's kind of what a computer program is. You are writing this much code, and you feel like, hey, that's a lot of code, right? That's not a lot of code. You know how much code is actually working just to keep your screen running, to make the window with a little box in it, that, you know, all the things that are going on inside of your computer are actually built on years of people that have been working on this for a long time. When you call println, in fact, those numbers have to be translated into individual pixels that light up on your screen. And you don't want to do all that work. Of course you don't want to do all that work. So Java's done it for you. they provide a command called println, and it just does all that stuff. This is called abstraction. So there's an important word to know. Abstraction. The idea of abstraction is maybe you don't know how it works, but you know how to use it. My analogy for that is driving a car. I kind of know how a combustion engine works, but I've never built one. Yet I can drive one. I know because here I am. I got to work today. Well, you can write code without having to be able to write a print statement because there it is. Okay. When you use parentheses in Java, that says I'm making a call. So this is the name of the recipe, and inside of parentheses you put the arguments or parameters. These are the things the recipe needs to work with. What's the analogy there? If you're making a cherry pie, I guess you pass it cherries, and if you're making an apple pie, you pass it apples, and then either way it works with the same recipe? Okay, bad analogy. It's not a recipe, but parameters are given to the print statement to tell it what to do. In this case, it's what to print. I'm passing to the println function just one parameter, and that parameter is a string, and that string is hello. And strings are indicated by quotation marks surrounding a bunch of characters, and this is what it's going to print. If I omitted the quotation marks, what does that mean? Yeah, that means this is a variable name, and there better be a variable name. String hello equals yo, dude. Something like that. This is a declaration of a string hello. This is an ooh, what did I do? Sorry. This is an initialization of that string, and here I'm passing that string variable to the println function. And you could do it that way too if you wanted, although you'd have to do this to actually follow the instructions. As you can see, there are many correct answers to this, but if you achieved printing and you knew what you were doing, you got it correct. Any questions on that so far? Awesome. Number 2. Using a for loop. By the way, did you know you can drag these boxes as big as you want to? Okay, good. Write code that will count from 0 to 99. Okay. How should we start? Yeah.
I wrote.
And that's absolutely correct. Okay. Let's talk about this. What does for mean? It's for counting, basically. Int I. This declares a variable named I. This initializes it to 0. By the way, you could write the same thing like this. You could say int I, and then you could say for I equals 0, I is less than 100, I plus plus. That's just breaking it up onto 2 lines, if you want to.
Okay.
And in fact, you could even initialize it in front of the loop if you want and do nothing at the start of the for loop. All of those are valid and equivalent. Yes?
That will run the exact same way?
They will all do exactly the same thing. Now, I should qualify. When I say they'll do exactly the same thing, what exactly will the user see this doing? Absolutely nothing, right? Now, I didn't say to do anything. I said count to 100, and in fact, or count to 99. And that's what this is doing, is it's counting to 99. But as far as we know, nothing's going on. So usually, you don't put a semicolon right after a for loop. That's just kind of pointless in general. We're going to want to do something like, like say system.out.println I or something. Now we're actually seeing a bunch of numbers go from 0 to 99, and that's a bit more useful. Therefore, in fact, let's say println. Otherwise, they're all going to run together. So I would recommend never ever allow a semicolon to follow a for loop. Look at this code right here. Anybody see the bug? This is perfectly valid code, but there's a nasty subtle bug here. Now I think these days the compiler will warn you when you put a semicolon after a for loop. It didn't used to. And I have spent so many hours in the lab chasing this particular bug that I'm going to warn you about it anyway. Here's the bug. The semicolon means, okay, go. All done, right? So what this code really says is count all the way to the 100, then the next line is print I, and then it's done. So I didn't print 100 times, I just counted to 100 and then printed, and that's a bad juju. You don't want to be doing that. So nix that semicolon. Never put a semicolon after a for loop. Even though it's technically correct, it kind of basically means don't do anything, just count. Now we're counting all the way to 100, or 0 to 99, that is. Okay. This is the condition. It's only going to do it as long as that condition is true. This is the incrementer, or the iterator. This moves your number on to the next value. Suppose I did this, int j equals 0, and I said j plus plus. How's this code going to work? Well, it's going to do something. Yeah, it's going to print the number 0 over and over, and it's going to say 0, 0, 0, 0, 0, 0, 0, 0. Meanwhile, j is getting bigger and bigger and bigger, but I is always 0, and I is always less than 100. So we're just going to see a whole bunch of the number zeros. These types of bugs are really difficult to see. You have to kind of look really closely and read the variables carefully to notice that, hey, your condition is based on I, but you're actually changing j. Now, what if, just for hypothetical's sake, inside of the loop, I said I++. Is that going to work?
Yeah, but it's not going to start at 0. It'll start at 1.
So, yeah, this will actually work. I is going to start at 0 because I set it to 0 right there.
But it's not.
I'm going to go into the for loop.
Count, right?
First thing I'm going to do is increment I, and then the first number it'll print will be 1 because I'm incrementing before I printed it. Keep track of, did you increment before or after? That's one of the reasons they put it in the for statement, is because you're usually thinking about incrementing right here, but you don't really want it to increment till after you did this stuff. So I guess that's the rationale behind it. There's something called a while loop. It looks like this. You can say int I equals 0 while I is less than 100. And down here you can say I++, and here I could say system.out.println I. Just looking at this example, what does a while loop do? Yep, it's exactly the same thing as a for loop, except it only takes one parameter instead of 3. And the parameter is the condition. So with a while loop, you have to do the initialization yourself before it, and you have to do the incrementing yourself in your loop. Is there anything you can do with a for statement that you can't do with a while loop? Yeah, you can fit it all onto one line. That's about it. Yeah, I'm kind of jumping all over the place for learning's sake. This is confusing as heck code. Don't look at that one. So, yeah. I think what I meant to say is this code is exactly the same as this code.
Okay.
Yeah, sorry for being misleading there. Yeah. A while loop does the same thing as a for loop. It just doesn't provide these two extra convenience spots. The first one for declaring some iterator variable, and the last one for incrementing it.
The for loop, it needs to be the condition, the increment. I mean, all that has to be in there.
Yeah, I would say initializer, condition, and final or incrementer. Yeah.
On the second one, you don't have that in the while loop. You just have it. You have it outside.
That's correct. While loops only take one parameter, and it's the condition.
Okay.
So you really can't put extra stuff in the while loop. Basically, think of it this way. While loops were probably first. I bet you they invented the while loop, and people were coding along with them for years, and then somebody noticed, hey, we do this pattern so often. Declare a variable, use a while loop, and increment it. Let's just make life easier by cramming it down into one function, and let's use two fewer letters just to save typing. I'm guessing that's how the evolution of the for loop happened. You could use while loops all over in your code, but hey, this is more code and it's harder to read. This is less code and it's slightly easier to read. Okay, why does it count to 99 instead of 100? Because I said less than. And very often in programming, we like things to be zero indexed. It's just the way it is. Life is a little easier if you zero index everything, so I just recommend you get used to it, even though it seems counterintuitive at first.